Hello guys, in today's tutorial we want to see the earthquake risk area, how to calculate the earthquake risk area using the historical data, geological faults and lithology variation through geological study, and put in the ArcGIS Pro the data, and they will be show easily where is the red spots and where the magnitude will be high and where will be the future prediction of for the earthquake, major earthquake. So in this tutorial we can see in the ArcGIS Pro. So you can, in this map you can easily see it. The earthquake risk area is very more along this Himalaya ranges because it's a very thrusting fault occur in this area. So there is a high magnitude of earthquake is coming in the past, coming in the future, and it's come in the past. So you can also make it in the ArcGIS Pro easily. For this you can firstly go to DevaGIS, and where you can where you can study, you can download your shapefile of that area and convert into the polygon to raster. So by polygon to raster, so it will be give you a very unique and every discrete data of this shapefile. So in this polygon to raster, so whenever in the next step you can go to the kernel density. In this density you give the Excel data of the past, or the, for example, fault or geological events which are occur in these areas. So you can give the data in the environment. You can give the raster image, so it will be create you this kind of kernel density, uh, in which they show the points which are near to the faults, or those rocks which are prone to the earthquake. So they will give the red spots in your map, so it easily see that this area is mostly like prone to the earthquake, or futurely there will be highly magnitude earthquake will be coming. So then we will go to the IDW, which is inverse distance weighting. It is also a tool in ArcGIS Pro. So it will be give the closer point to the earthquake. So you know that this is the points of the earthquake which are occur in the past. So by giving the data of this one to the IDW, so it will be generate you this kind of raster image. So it easily interpreted the green area. It represented mostly earthquake will be coming, or earthquake will becomes. So this IDW for firstly you can create for the magnitude of the earthquake, and then you will be create for the depth of the earthquake. So basically this is the IDW for the magnitude in the depth of the earthquake. So there is two classification by based on the symbology, classify symbology, and the stretch symbology. In the classify symbology, you can see that the data will be discrete representation. We will be see in the ArcGIS Pro, and the stretch symbology, it will be show the continuous representative. But for the IDW, mostly the stretch symbology, they will be show you or they will be show the heat map, elevation data and density analysis in ArcGIS Pro. The next you can give the fault lines of your area, and also put the this earthquake data. So it will also give the where is the prone region to the earthquake. The red line you can show the which is very high risk area for the earthquake. Then you can also create it your in study area the Euclidean density. Euclidean density means the distance. It basically calculate the distance from the where the earthquake is coming in the past, or near to the fault. So it's mean that in this green area the faults are very more. So it's mean that this area the earthquake is very more. So it give easily interpretation that the green area is very high risk area and very earthquake more in this area, and this color means there is no faults, no rocks which are prone to the earthquake, so less earthquake is coming in this area. So you can also create the kernel density. Kernel density, any kernel density, it will give the density of the rock by the raster representation. So by fault line, so you easily see it. It's although there is a faults in this area, but these faults are very messy in nature. So it's mean that these area are very high prone area to the earthquake. Then then we will be add to the spread field. Spread field means like those rock which are highly p and s waves of the earthquake they are passes. So there are different types of rock and they are the different speed. So in this you can see 1600 is like diorite or shale and limestone. These are the geological data. So you need to geological data, you need to this kind of excel sheet, and you can put and you can create a new shape file, a new column in which you can put the data of the each of the rock of the speed. So by this calculation, so you can also create a raster image for the different rock of the in the study area and their p and s wave pass in these rocks. So by creating these every kind, so you can see it, you can create this kind of feature. So it's mean that in this red area there is the rocks which are high dp and s wave pass in these rocks. So it's mean that these area are very prone to the earthquake, and the blue ones and the green ones mean that it's less prone to the earthquake because these rocks are not pass p and s wave, or very less s and p waves are passing these rocks. So by collecting this geological data, fault line data, kernel density, Euclidean density, so you can easily see these areas are very every raster image they show the red area. So it's mean that uh, it will represent a high magnitude of earthquake or future prediction of earthquake. So now uh, you can I will go to my ArcGIS Pro. So you can firstly you can see it, it's the stretch means like it will be give the like a continuous symbology or continuous different variation from the high magnitude to the low magnitude. But when we go to the classify, so it will be give the every point of your density, that these area have this magnitude and these area have this magnitude. So most of the for example, if you create a heat map, so you will be use the classify symbology. But whenever you use the like earthquake or elevation model, so you mostly created the stretch stretch symbology. So it will give the continuously imagery of your data. So then this is the whole data. This is the for IDW or the earthquake. This is for the faults. It's mean that it's very high dense fault in this area, and this is the low density fault. And then you can go to your this portion. So you firstly visit to the your shape file of the IDW shape file, means the like a density of the rocks or density of the fault lines. Then you can also see from the lithological S&P West pass, and these are the different like faults which are near to the your study area. This is the, if I remove everything and create, okay, okay. So firstly if I remove it, so it's mean in our shapefile area, so past earthquake are coming in this area, so it will give the historic representation. So it's mean that mostly earthquake in this area. So whenever I open the false line, so it represented this area have maximum fault in this area. And if I open the geological data, so if I go to my right click and open attribute table, so you can easily see it that this is the various table, and this is the lithological symbol. So if you click it in this area, so it will be represent you the dolomite and this which is the Spanish language. But in this area a maximum SV and P waves are passes. And in the last we have this raster image in which we create this kind of everything. So you can easily create it like this kind of map of the earthquake, and show your study area where the earthquake are more prone to the magnitude or depth of the earthquake. So this will be our final map. So it represented this area is more prone to the earthquake, and in the future we will be for the planning of the housing or the planning of the some geological big project like dams. So you will be mostly notice this area. So hope you will be learn something from this tutorial. We will be meet next in the new things in the ArcGIS Pro.